Good morning. I'm Mike Simmons with the Tennessee Job Training and Safety Program, and I'm here to tell you about material and equipment transport for utilities. Our program today will cover near misses and close calls. We'll talk about truck and trailer inspections, Penal Hitch inspections, pole transport, tool and equipment storage, material storage, and transport. And then we'll summarize everything up. Now, as always in our programs, we discuss near misses and close calls that have occurred around our service area or anything else that anyone has been involved in. It's very important that you deal with near misses or close calls so that we try to prevent the actual incident from becoming more serious or happening at all. So at this time, if you'd like to pause this video and take as much time as you need to discuss any accidents, injuries, near misses, or close calls that have occurred, be a good opportunity. All right, I hope you had a good discussion. Normally when we do our face-to-face meetings, we take care of that, but with this pause, I hope you're able to move forward with that discussion of near misses and close calls. It's a critical part of every safety program. All right, so what are we going to cover? We're going to point out some of the most common hazards that may occur when transporting material and equipment. We'll present and discuss some ways that hazard can be recognized and avoided or corrected. We'll also present some of the basic regulatory requirements when transporting material and equipment. Before any transport, you should conduct a pre-trip inspection of the truck, chassis, and bed according to DOT and requirements and company policy. Conduct a thorough pre-trip inspection of any trailer or towed equipment, again according to DOT requirements or company policy. You also want to conduct a thorough inspection of any hitch components before mating a trailer to a truck. And finally, conduct a thorough inspection of all material or equipment tie-downs before heading out. We're going to put special emphasis on inspection and connection of pintle hook towing connections. These are among the most frequently used towing connections by utilities. They're a common heavy-duty towing connection, and they are not infallible. They can fail just like anything else, so they should be looked at closely, and you need to ensure their proper function and capability. First, inspect the pintle hitch. Look for wear or cracks or deformity in the jaw of the hook. Check for free motion of the latch and spring if it's equipped with one. Check for free rotation, and check the bolts and welds to make sure it's securely fastened to the towing vehicle. Next, look for deformity or cracks in the ring or mounting base. The lunette ring is a critical component, and we'll talk a little bit more about how to measure that. Check for wear of the ring and check with an appropriate gauge. Also, make sure again you check bolts or welds. These are common fail points. A number of manufacturers and suppliers have for sale rings that are specifically designed for checking the wear and capabilities of lunette ring hitches. We do not promote any particular brand, but we do highly recommend that you obtain one or more of these gauges and use them regularly in your inspections. Keep in mind, this inspection is not just for your annual DOT inspection, it's for regular periodic inspections before use. Check your safety chains and hooks. Check for wear or distortion of the chain links. Each and every link. As the old saying goes, a length of chain is only as strong as its weakest link. Check for excessive rust or wear at toe points or low points and attachment. The bottom of the curve is a typical drag point, and drag means wear, and wear means loss of strength. So you want to look closely at that section. Check hooks for cracks, wear, or deformation in the throat of the hook, along the shank, and in the eye. Verify the safety latch is in place and functional. Also, you want to check your connections. Ensure the chains are connected individually and securely. Cross the safety chains below the drawbar. Crossing of the safety chains provides a cradle so that if the tongue becomes detached, they will rest on the safety chains while towing and prevent the tongue from digging in and flipping the trailer. Also, verify the length of the safety chains. There's been a recent change in National DOT policy, and rolling or twisting the chain in order to shorten it is a recognized and approved method for adjusting the length of the chain. Don't tie a knot in it, but you do want to roll it or twist it, or actually just have the appropriate number of links in the chain. Landing gear is a critical component of every trailer or towed vehicle. The landing gear keeps the tongue up when you're getting ready to hitch it. Be sure to fully stow the landing gear. Make sure it's completely swung or retracted. Use the provided locking pin on the latch. If the locking pin is not functional, don't rely on a collar rope, chain, or strap to hold it. This could fail during transport. Check emergency braking system. Check battery condition and verify charge. Check the electrical pigtail to make sure that it is in good condition and functional. And make sure that you check the breakaway lanyard, that it is in place and usable. Breakaway lanyard is a critical component of the braking system on the trailer. The last thing you want is a trailer passing you going down the road. There have been fatal and serious accidents that have resulted from the very same thing. When you are connecting the breakaway lanyard, ensure that the proper length and connection of the lanyard is there. You must have a separate connection point from the safety chains for your breakaway lanyard. And do not attach to the safety chain hook as you see here in this photograph. We find this to be a typical violation of the connection process. It seems like a convenient way to hook to it, but the whole point of the safety lanyard is to be able to trigger the braking system should the safety chains fail and the trailer become completely disconnected from the towing vehicle. So you want a completely separate location. Likewise, in order to shorten the lanyard, don't wind it up or weave it through the safety chain. It needs to be a free and separate connection. You can either get one of the spring type connectors that takes up its own slack, or you can fold it back and use a clamp in order to make the connection the right length. Now we're going to move on to material loading, a few simple steps, specifically poles. We're going to be dealing with pole loading and hauling in a more lengthy program later on in the season, but right now we want to talk about just the very basics. And with any lift that you're going to make, especially with pole lifts, inspect your sling and verify the capacity. You want to attach the pole at the appropriate point so you have a good balance point. And then once you've got the pole on your towing vehicle, you want to make sure that you secure the load at both ends to make sure that it's good shape. Also, with an extended load, you want to make sure that you observe appropriate local regulations for marking and designation of a excessive length tow. Materials, typically with transformers. Again, you want to inspect your sling and verify that the capacity is correct. OSHA regulations demand that the rating tag on the nylon sling be clearly visible and legible. so that you can tell exactly what the rating is on the sling. They vary from material and manufacturer to manufacturer, so you want to make sure that you get that right. You want to attach the sling at the appropriate points. You want to use a designated sling. And it's a common practice to use a length collar rope with a knot to make a sling out of it. JT&S does not recommend that, and it is not 100% in compliance. So use an appropriate sling for lifting and moving transformers. A length of so-called collar rope is fine for securing the load, but for lifting the load, you want to make sure that you have an appropriate lifting device or sling. And then secure the load in the cargo bay by whatever means you use. Some folks use a bolted secure frame. Some people use straps. Some people use a rope or other means of securement. Tool storage. We have to take a lot of tools and material with us. As the old saying goes, a place for everything and everything in its place. Store all tools and safety equipment properly. Avoid exposing PPE and safety equipment to excessive wear and damage. And do not store unsecured tools on the deck or in the bed of the truck. This is a common problem. We're going to drive slow. We're going to drive careful. But something always ends up happening. So let's make sure we've got everything secured when we put it out there. Store all material and supplies securely in bins or in designated containers. Do not store unsecured material or supplies on the deck or in the bed of a truck unless properly secured. Hauling equipment or material on a trailer requires securement that meets the Federal Motor Safety Carrier Administration regulations. More of us have equipment or material that we need to get out to the field now. We've got a lot of labor-saving devices and equipment that we get out there, a lot of new equipment that we use for access and difficult terrain. We can't just throw it on a trailer and throw a strap or a chain on it. We need to secure it properly and legally. We've obtained a video from the Iowa Department of Transportation. This is available online, but it's an exceptionally good video with regard to the specifics. And these cover the federal regulations which apply for us here in Tennessee and in other surrounding states. As with all federal regulations, we have to at least meet these. And if there are any specific regulations that go above and beyond these, you can check with your local Department of Transportation or with the JT&S program or some other regulatory body. Be happy to clear that up for you. But while DOT regulations may differ, all states must follow these minimum requirements from the Federal Motor Safety Carrier. So right now, let's watch this video, and we'll come back after the video is done.
Hi, I'm Officer Steve Robinson, Training Coordinator with Motor Vehicle Enforcement within the Division of Motor Vehicle, the Iowa Department of Transportation. We're here today to talk about chains and load securement, how to look at the chains, make sure you have the correct style chains and they're not damaged, and do a proper securement for a heavy vehicle. Before we start actually chaining down the piece of equipment, the first step is actually checking your chains over to make sure that they're not damaged and you have a proper type of chain to begin with. Most of the chains that the Department of Transportation has are going to be 3/8" transport chain. And the way to check that is, first of all, you're going to measure the width of the strand, and then we're going to take a look at each strand and make sure that there's a marking somewhere on the strand that says G7, L7, or something with a 7 on it to show that it's a type 70 chain. If it doesn't have any markings on it, we have to take it back to what's called a type 30 chain, which is basically about a quarter of the securement value of a full length chain. Before I start putting chains on the heavy equipment, I'm looking at the chain to make sure it has proper the proper width, and we know what type of size and type of chain it is, as well as looking for damage to the chain itself. To start off with, we're looking for a marking on the chain, such as this RG7 that tells us it's a type 7 or 70, or in other words, a transport chain. And then we're going to measure out the width of the strand, at which point we're actually looking at about 3/8 inches there. So the 3/8 inch, if I look it up in the book, for a type 7 chain should be about 6,600 pounds of securement. If there's no markings here, we're going to take it back to like this chain is over here. It has no markings on it, so we have to call it a type 30 chain. I also have several pieces of straps here. These are 4-inch straps. Unmarked straps usually get about 1,000 pounds per inch of width. So a 3-inch strap would get 3,000 pounds, 4-inch strap would get 4,000 pounds of load securement value. Any type of damage in it, especially for like a 4-inch strap, we need to have 3/4 inch of damage. Anything more than that basically violates the strap and it can't be used. These are 4-inch straps. You can use a 4-inch strap. You basically get 1,000 pounds per inch of width of strap. So the table would give us unmarked would say 4,000 pounds. If there's a marking on it that would say that it's valued at 5,000 pounds, we would give the value at 5,000 pounds as long as the tag was on the strap, still attached to the strap, and was legible. Now this strap has a little bit of damage in it, a lot of damage in it, and then there's more than 3/4 inch damage to the strap, and we're right at 3/4 inch damage there. This strap would be void and just needs to be thrown away or used for some other purpose. Shouldn't be used for your load securement. Okay, we're looking at this smaller chain here. It seems to be in good shape. We're looking for the marking on it. So there's a G7. So it's the same type as the other type we were looking at earlier. We're looking at the width here. It appears to be 1/4 inch in width. It's a 1/4 inch type 7 chain. We'll use the book to look it up. And this one here, again, was 3/8 inch wide. And it's also a type 70 chain. And then when we're down to a type 30 chain, or 3 on the strap, and we're also looking at a 1/4 inch chain. When we're looking in the book, we'll go to the type 70 for the two chains. You can see the 1/4 inch gets about 3,150 pounds of load securement value, and then on our 3/8 inch we're allowed up to 6,600 pounds. On the type 30 chain, it was also a 1/4 inch. We'd only get about 1,300 out of it. If we have an unmarked chain that we measured out at 3/8 inch, we would take that unmarked and move it all the way down to the lowest coil, the proof coil, and that only gives 2,650 pounds of working load limit. Other things I'm looking for in here is I don't see any type of damage to the links. I'm looking at the links side on so I can see that there's no twisting to them, and I don't see any type of stretching in the links. I'll show you a couple examples here in just a second of proper or improper links that are twisted or damaged. This does have a clevis splice on it, which is an acceptable repair. It's about the only acceptable repair that we'll accept to replace the original pieces. It has both cotter pins in place, and it also has both of the securement pins as well. On the other chain here, we're looking at several different repairs that are unacceptable and several different damages. You can see on this one that the link is twisted or bent. It's not going to be acceptable. We do not use bolts to repair links. It's also non-acceptable. You're looking for any type of broken links, again more bent. And back here, we're going to find a little bit of a figure 8 type setup, probably on this bent one as well. You're going to see a little bit of a figure 8 setup, which means that link has been stretched out, and a stretched link is not acceptable either. We've got several different type of repair items here that are common and sold at stores, but they're not acceptable for load securement. The first one being a weld link or a lap link. The second one here appears to be a cold shut link. Anytime you got to hammer your pieces together, it's not acceptable. The next piece here is called a quick link. It's not acceptable. And it looks like we got half a clevis here. The half clevis would be okay for a certain amount of your repairs. Got one more type, which would be a quick link. This is one side or a half of a cold link. We're going to put the other half on here. Again, that's not something that's acceptable for load securement as a repair. The last thing we'll kind of discuss is we already kind of looked at the table for the chain. If the chain already has a piece of a tag on it that tells us what the load securement is listed on here, so we'll find usually a stamp inside here that will tell us how many pounds that it's secured for. As long as that tag's still attached to the chain, we'll go ahead and we'll use whatever value is listed on there. Okay, we're going to start off by putting chains. We need with a heavy piece of equipment that's over 10,000 pounds, we need a 4-point tie down and then a direct tie down method. So we're going to start off with Tim putting the chain on. We would like to get it at a 45-degree angle at all possible. You're going to see this first attempt probably going to not work out too well for Tim. First thing we're going to do is we're going to hook into the pocket, into the rub rail, and he's going to make, Tim's going to hook into an eyelet provided by the manufacturer. You can see it's coming over the top of another piece of part of the equipment. And as he puts on his binder to do a tighten it down, we're not going to get a good 45-degree angle right off that eyelet. It leaves a lot of opportunity for the device to loosen up and cause problems. So it's not a good securement method. We're going to actually use a cross-chain securement method. Tim's hooking into an approved pocket. This is provided by the manufacturer, and he's going to come underneath the arms of the bucket. Creates fewer spots to rub against the chain. He's also using a side pocket a little bit further out to get a better 45-degree angle tie down off of it. As Tim hooks this into this, you notice he's going around the whole link and not trying to put the hook inside the loop of the link. He's going to tighten down, and we got a nice good 45-degree angle on this. It works much better for securing, keeping forward and sideward movement from occurring. You notice we have a hook point here provided by the manufacturer of the heavy equipment. It does not lend itself to a good tie down spot with this particular chain, so we went ahead and had Tim hook up to the axle, which is an approved method for your 4-point securement. One thing you want to make sure when you're doing a securement to an axle, though, is to make sure that there's no brake hoses, tubes, or other type of airlines available or going to be damaged using this method. Okay, with this particular chain, we have a smaller hook that we're using, so it went through the tie down point that the manufacturer provided without any problems. So we'll go ahead and we'll use the tie down point versus using an axle. Tim's going to rehook this with his ratchet device pointing down on against the deck, against the back of the trailer here. One of the reasons for doing that was keep the device from popping open as it's driving down the road, which is one of the requirements of our load securement. We need to make sure all our chains and load securement items are not capable of opening up while in transit. What we're doing with the extra chain here so it doesn't pop out off the side of the vehicle and possibly damage a car driving by. And it also supplies a securement method for the ratchet not to come unhooked while it's going down the road. Here we have two chains that are just too short to make the securement work. A lot of people would go ahead and try to make one longer chain out of the two chains, and that's not an acceptable method. You cannot interconnect chains to make one longer chain. What we did here is we have to lower the bucket as part of one of the requirements for anything that's over 10,000 pounds, blade or end loader, as well as chain it down to the deck. In this case, we used a smaller chain, couldn't quite make the hook, so we went ahead and hooked the binder right directly into the rub rail, which is an approved method as long as the rub rail doesn't have any damage and it stays tight. We've gotten all 4 points on this particular vehicle. The bucket's been lowered down to the deck, and we've added the securement chain to it to make sure it's secured. A couple of things that we're going to do is we're going to make one final check of the equipment to make sure that everything's secured down properly. The first thing I've noticed when I did my walk around on this is the chain is not tight. We're going to make sure that we either tighten this back down or grab another loop or two to make it tight. Then on the back here, with our tie down, one of the reasons we want to do a 45-degree angle is we got to prevent movement from up, down, left, right, and backward and forward. And with coming back to the back here like this, we didn't get that 45-degree tie down, so we'll still prevent backwards and forward movement, and to a certain extent some side-to-side movement, but we're not going to be able to do a lot with the up and down movement. We're not getting enough pressure on the downside to make this work. It'd be better if we could hook it into this pocket. If that's the case where we can't reach that pocket, then unfortunately we'd have to unhook everything and move the loader forward so we can get that 45-degree tie down. Okay, one of the last things we need to do for load securement is when we have a piece of equipment articulates side to side, we need to make sure that if we have a mechanical locking pin like we have on this particular machinery, that we put the locking pin in place and make sure the locking pin's firmly secured with the cotter and the hairpin. We have this locking pin in place now. If the machinery was missing the locking pin or did not come with a locking pin, we'll need to go ahead and do a 4-point tie down with 4 chains on the front and 4 chains on the back side of the piece of equipment to lock out that articulation. The last thing we're going to look at when we're doing our walk around before we drive away with this piece of vehicle is want to make sure that any rock, dirt, and other heavy debris is swept off the deck here. You use a broom, hand, whatever you need to do to get rid of as much of it as possible. This is one of the biggest complaints the DOT gets as far as the rock comes off, goes through somebody's windshield, and it's a claim that we would have to pay out, or the trucking company would have to pay out. On behalf of the Department of Transportation, I'd like to thank you for watching, and remember that safety.
Okay, that was a good video. It covered a lot of good information. Obviously, there's a whole lot more things that can be dealt with out there with regard to tying it down, but following those basic principles, making sure that you check all of your tie down equipment and material, make sure you do a thorough inspection of the trailer that you're going to be towing the material on, and make sure that you follow those basic principles for tying down the load will be a long way toward getting you into good shape and being in compliance, and most importantly being safe going down the road. So if you have any questions or comments, feel free to reach out to your normal JT&S instructor who comes around on a regular basis, or you can contact me, Mike Simmons, here at the JT&S office, or reach out to any of the Tennessee Department of Transportation offices or officers that you can access, and they'll be happy to help you out with it. We'd like to thank the folks at Meriwether Lewis Electric Cooperative, these two gentlemen specifically, for helping us put this program together. Thank you for your time. As always, be safe, be healthy, and watch each other while you're out there in the wild and woolly getting things done. Thank you, and have a very good day. On behalf of JT&S, be safe.